Example 5 from 3.4, use a graph in your knowledge of the zeros of polynomial functions to determine the exact values of all the solutions of that. So if we go through like we usually do with solving a polynomial, it's usually f of x equals this, and we set it, and we find the zeros. This one's equal to 0, so we're basically just solving the equation. All right. If we look at this as being f of x, we have one sign change, two sign changes, and that's it. So we know there's, for positive solutions, there's either 2 or 0. And then if I do f of negative x, that's x to the fourth plus 5x cubed, sign changes, plus 4x squared, sign doesn't change, minus 3x, sign changes, plus 9 doesn't change. So even powers stay the same, odd powers change sign. Positive stays positive, stays positive, switches to negative, and switches back to positive. There's two sign changes, so for negative, there are 2 or 0 negatives also. And again, it always goes down by 2 because if it's a complex number, the complex number and its conjugate, not counting as positive or negative numbers, so any complex answer deducts 2 off each one. So we're looking for that for the number of possible solutions of each type. Again, the function I care about is this one. So once I've established this stuff, get f of negative x out of there so that you don't think that's important anymore because it isn't. If I do my possible rational roots here, PRR list, it's all over 1, right? Because coefficients of 1, all right? And there's both positive and negative possibilities here, so I have to put plus or minus in all my things. So plus or minus 1, plus or minus 3, or plus or minus 9. So if I type that function in now as y equals, and for those of you who watched the video or in class today, I went to mode, switched from math print to classic, so now I don't have to worry about getting out of that power level anymore. So x caret 4 just looks like that. And then once I type the power, it is what it is. If it's like x to the 12th, I have to put parentheses, 12 and parentheses if there's more than one character. Minus 5x cubed. If you still like the math print, go ahead and do it. I forget to get out of that level so often, I don't like it. So plus 3x plus 9. And there's my function. I'm going to go to my table, and the numbers I care about are 1, 3, and 9, plus and minus. And I can see 3 works right there. I'm just going to, oops, I'm going to delete the ones that are there and just put plus or minus 1, 3, and 9. So 1, minus 1, 3, minus 3, 9, minus 9. And what we see is that 3 works, but nothing else works. And what we did before was we just assumed that 3 happens more than once, right? But we don't know that for a fact. And this does very clearly say exact values. So exact meaning that if it's 3, they want 3. If it's a half, they want a half. If it's 2 plus the square root of 7 over 5, they want it written like that instead of decimal versions of those. So the fact that it's a 4th power polynomial means I need to get 2 answers to get down to that exact thing. So hopefully 3 works twice. If I were to graph it though, I'm going to set my window just to, I'm going to do a standard zoom, just negative 10 to 10 in all directions. Maybe I'll do a standard zoom. I remember how to use my calculator here. Zoom. And number 6 is standard. That just goes negative 10 to 10 on x and y. There it goes, and then there it goes. All right. Now, looking at what happens at 3, it touches and turns. That tells me that by the even and odd powers of x minus c theorem, our favorite name theorem, that it's got an even power, 2 or 4 probably. It can't be bigger than 4 because it's only a 4th power problem. But 3 happens multiple times. If it were a 3rd power, it would still cross. All right, so we can still make the assumption, since we need at least 2 answers, we can make the assumption at that point that it probably happens more than once. All right. So by the graph, I know it happens at least twice. I know 3 works because I tried it in my table. So at this point, I'm going to do a synthetic division with 3 into the polynomial function 1x to the 4th minus 5x cubed plus 4x squared plus 3x plus 9. And doing the synthetic division once, getting a remainder of 0 because 3 works. 1 comes down, 3 times 1 is 3 plus negative 5. 3 times negative 2 is negative 6 plus 4 is negative 2. 3 times negative 2 is negative 6 plus 3 is negative 3. 3 times negative 3 is negative 9 plus 9 equals 0. So we get the right remainder. That took me from a 4th power polynomial here to now a 3rd power polynomial here. I'm going to apply synthetic division with 3 again for this one, expecting again a remainder of 0. Bring the 1 straight down. 3 times 1 is 3 plus negative 2 is 1. 3 times 1 is 3 plus negative 2 is 1. 3 times 3 is 3 plus negative 3 is 0. So that means at this point x equals 3 multiplicity 2. All right, 3 is an exact answer, so that's good. The remaining polynomial is x squared plus x plus 1. Now we're trying to solve x squared plus x plus 1 equals 0. This is a quadratic function. It is not factorable. So I'm going to go to my quadratic formula. Now, if I type my quadratic formula in, so go to my program here, hit quad, program quad, enter, and I type in my 1 and my 1 and my 1, those aren't exact. Those are approximate. Once you start seeing decimals, you're looking at approximate answers. So what I want you to do for this, if it does ask for exact answers, is actually do the quadratic formula by hand. All right? We know x equals that structure. What goes in this spot is opposite of b. B is 1, so negative 1. What goes in the bottom is 2a. A is 1, so 2 times 1 is 2. Again, those are easy always. What goes in here is b squared minus 4ac. B is 1, so 1 squared is 1 minus 4 times 1 times 1, because a is here also 1. So 1 minus 4 makes negative 3. That gets me x equals negative 1 half plus or minus the square root of 3 halves I. With the complex answers, make sure you keep them separate like that. So the real part plus or minus the imaginary part. We're going to start investigating that a little more thoroughly when we get to trigonometry. So getting that idea of breaking the structure apart is helpful. Comma 3 multiplicity 2. And that gets me my list of 4 exact answers. Notice we have 2 positive answers. We have 0 negative answers, because again, that doesn't count as positive or negative because it's imaginary. So the Descartes Rule of Signs work for us there to get the right thing. Possible rational roots got us a root. Again, the reduction of the polynomial from a quartic to a quadratic, to a cubic to a quadratic, allowed us to use a quadratic form to get the exact solutions to the ones that were actually complex and or irrational, if that happens.